Yes, sir.
Hmm. So in this class, whatever the topics are left, so I think in this class I should take one example of implementing inheritance, because in the last few classes I mainly talked about the features and the internal details of the features. So we will consider one specific implementation of queue and the stack class and the dequeue class using the list class. Okay, so we'll syntactically also we'll see that how the whole code can be written and how it works, what mode of inheritance we would like to prefer. But before that, let me talk about the composition of the basic debate of whether we choose composition over inheritance. I mean, specifically, whether we choose composition over multiple inheritance, because of the problems that we found that uh, if we have in our design, if we have designed or proposed a class design which has included multiple inheritance, there might be several issues that might occur, and you have to be very careful in resolving those issues. So the basic question is, can we get rid of it from the design perspective? Can we make a alternative design which will not have any case of those diamonds arising from the design or even multiple inheritance? And does it make sense also? Because it may happen that the problem that is given, the multiple inheritance, is very obvious, but even if it is obvious in terms of the design, can you replace it by some other option? So this is one topic, just one slide I will be talking about, then I will switch to that particular example. And once I finish that, there will be two main uh, topics. One is the templates, which I hope I'll be able to discuss tomorrow, and almost 1 hour, 1.5 hour class will be good enough. And then there will be one more topic, that is exception handling. So that more or less completes the entire syllabus of this object-oriented design using C++. Okay. So coming to this particular slide, so this is an example, as you can all see or read from that example, that we have got uh, a typical gaming application kind of scenario, where these are some representative classes. We have got the game object, and we have got different types of objects, different types of game objects under that. So game object is a more generic type of object, which includes a uh, methods like update, draw, collide, and all this. And within that, you have got visible, solid, and movable. So some of the objects are visible, some of them are solid, they are not uh, moving, and some of them are movable. And if I consider concrete examples of game objects, it can be a building, it can be a player, it can be a trap, it can be clouds. Okay. And as per the problem or the scenario, you can expect that, say, a building can be, so these visible, solid, and movable, these are all game objects. Specific type of game objects. So these are more or less this can be modeled as a user relationship. Specialized type of game objects, and these are also specialized types of game objects. So where a building can be visible as well as solid, a player can be visible, solid, as well as movable. So it can have all the three type of properties inherited from the three, like that. A cloud can be uh, visible and movable, but it will not be solid, so it will not stay still. A trap can be solid, like that. Okay. So given this say the description of the problem, this can be one class design. And as you can see here, up to this level there is no multiple inheritance, but when you consider these level of classes, then there is it involves multiple inheritance, and it involves that diamond issue also. This game object, visible, building, solid. So this is a diamond that is involved. So such a design, if we allow, it will create all sorts of side effects, and you have to deal with it. So to avoid this complex inheritance hierarchy is to create classes. So how to avoid this? Now to avoid this, we can think of like visible and solid. That can be one. So we say that instead of having these three, are you getting my uh, the problem or the issue that I'm discussing?
Yes, sir.
Hello, a bit louder. I cannot hear you.
Yes, sir.
The sound is.
Yes, sir.
Can you speak a bit louder? I don't know whether sound here is not working or not. Is this okay?
Yes, sir.
Hmm.
Yes,
Okay,
sir.
now
Yes,
it's
sir.
better. So the thing is, one simple way of getting rid of it. Can you can you figure out how it can be eliminated? See, this building is having the features of both visible and solid. Okay, so if this happens, so straightway you can think of that. Apart from having the classes visible, solid, and movable separate, if I create, or if I have one more class which is visible and solid, another one which is visible and movable, like that, so probably this will through that we can get rid of the multiple inheritance problem, right? Because you, in that case, you will have the topmost class, you will have these three basic uh, you will have the basic classes, and then a combination of these two. So this visible and solid, then this solid and movable, then this visible and movable, like this. Now if I would like to have such a design, then this building, so building may be just having visible and solid, so building will have, would have inherited from this, right? So building would have inherited from this, so there is no need to, so apart from the subclasses which are inherited directly from this or this, there is no need to do something like this, so the multiple inheritance can be avoided. But how many subclasses need to be defined in this particular layer? In that case,
7.
hello,
Hello. Sir, am I audible?
Sir, 7, sir.
hello, can you speak a bit louder?
Sir,
Sir,
7.
will it be 7?
Yes, so there are three, and then if you combine, you have got all the combinations and permutations. So it may be taking two at a time, taking three at a time, like that, right? So this actually complicates the whole design also. So another, so this is one, but this is one option that how you get rid of it. So the number of classes becomes exponentially large, and it becomes a very clumsy design. So this is one, but this is one option, right? One option to get rid of multiple inheritance, and this is the option 2. So what is option 2 now? Now you deviate from your basic understanding of how the classes are inherited or all these things, right? What it says, another solution is to avoid complex inheritance hierarchy is to consider one major simple hierarchy, right? So as you can see here, so I just want to have a basic structure of this very complex hierarchy, and I would like to remove the rest of it from it, and then define some classes as a composition of the other classes. Okay, so this building, see, game object, solid, and then there's a building. Okay, so this building, it must be inherited from the solid class, which is in turn inherited from the game object class. But building also, earlier we told that building is also inherited, is a solid class also, but now I say that sorry, it's a solid class, but and it is also a visible class. Now I say that building has a visible component. So this is a, so we have got visible as a separate class. Now I say that let me retain this hierarchy, which is the largest possible, which accommodates probably the largest possible classes from this complex design, and then to take into account the arcs that I remove. Say building is also is a visible, uh, is a type of visible class. I say that let the building be constructed, or the building class be defined as if it has a visible component. So it's a kind of has a relationship. Okay, so you can think of like this. It's a has a. So now you might say that, okay, so that means earlier which was modeled as a is a relation, two classes, now the same two classes now are combined using a has a relation. So then that means hisa and hasa, they are almost considered to be synonyms. Now what's the point of making so? So there might be, so that's why the debate comes. So this is not straightforward in terms of the understanding of how the classes are derived and what is the semantics of them. So you are basically changing the semantics, right? The basic meaning of how one class is related to the other. But at least if you somehow, so this has also can use the features of it, so the reusability is still possible. And as I mentioned, that you get rid of the all those complicated issues that arise due to the mutual inheritance. So that's why the composition over inheritance, it's a basic debate, or the composition composite reuse principle in object-oriented programming, or I would say the object-oriented design, is a principle that classes should achieve polymorphic behavior and code reuse by their composition rather than inheritance.
Sir,
Yes.
sir, but even in this method, we need to redefine 2 power n minus 1 new classes, no, sir. But why are we doing this? Because means this is
Which
also
one?
not an efficient method, no, sir.
Which one? I'm not getting. Which one you say? Option?
Means in the left hand side, you said as it is clumsy, we need to uh, redefine by making new classes. But even in that case also, if we have more number of classes, it will become very complex, no, sir.
Now, are you talking about option one or option two?
Option the reason we are changing from option 1 to 2, sir.
No, no. See, option. It is not the reason. I mean, one thing is, yes, the number of classes are too many, but here you see how many classes are there here. 1, 2, 3, 4, 5, 6, 7, 8. Now, okay, you say that if there is some other class which is inherited from visible, solid, and movable, like that.
Yes,
That is
sir.
what you say. So you have to create that class, and only then from that you can inherit it. But in
Yes.
this case, you see, if you have got these basic classes, so you can always write has a visible, has a this, like this. Are you getting my point? So if you create a new box here, say for example another blue box here, okay, which is in this level, and if it happens to uh, I mean, if it is having features of type is a visible, solid, and movable, all the three. So for that, probably you have to have a separate box of that level created, because if it is not there already, maybe you have combined two of them at a time, visible and solid, solid and movable, visible and movable, then like that. Okay, but now you, you require to define another class which is having the features of the three of them. So first of all you have to create this, and only then you can create this through this kind of inheritance. Are you getting my point?
Yes, sir.
But here if you need maybe another class, here I also need another class, and which is having all the three. What do you do here? I mean all the three features, solid, visible and movable. Now you say that let me inherit it from the solid, and let this to be haza. So the thing is you add this class, that is the demand, but you don't create an additional subclasses of the hierarchy. There is no more subclasses required. Are you getting my point?
Yes, sir. I was asking if there are more number of such classes, it will become difficult. I was saying that
More number of classes of which level?
in the second level here we are
Mm.
having three parts, no, sir.
Mm-hmm.
Means if there are more number of such things, it will become difficult for us to
Yes, you say that if
cover all the combinations.
okay, you say that out of the all the possible permutations, if we have few of the valid permutations and the rest are not required, still we can stick to that, right?
Yes, sir. Yes.
Yes, that is what you say. But when you say it's a design principle, so you are not sure. I mean, maybe in future you will come up with some situations or some new requirements of classes which require the combination of some classes which is unforeseen. So you cannot foresee all the design at a at a certain point of time. So the object oriented designs are generally expandable, and these are extendable. You may not have the complete idea of the entire design uh, well ahead of time. So you may have a basic outline, and from based on that you design. And then once the system is deployed, based on the client's request and based on the problems that you face, you might upgrade your design, which adding more classes and all. So when you first define the basic class hierarchy, you may not have the idea that what you are going to face later on. So there may be other issues also. But again, this is not that it's a kind of the only solution that resolves everything. But these are the kind of options that one might have. Even this also works. If you can implement, this also will work. But what they say is it involves complex inheritance, and probably you have to keep in mind lots of issues, and which may not be easy to handle in a very large class design. Okay, so these are the options. As a designer, you should know that what may be the other possible options, and maybe that it is not that in your design you don't have mutual inheritance at all. You might have mutual inheritance, but whenever it's possible, you try to get rid of it and maybe stick to option two. Okay, is that fine?
Yes, sir.
Yes, sir.
So try to appreciate the non-trivial issue in designing a class hierarchy. That's most important. So for designing simple like inheriting stacks and queues from lists and all, there you may not think so much, because you know that 6-7 classes I can handle. But sometimes a class design may involve several hundreds of classes, and you will simply get lost out of it. So these are the things in the design, and in fact object oriented design itself is a course which is offered in many many other as an elective sometimes also. So we are trying to talk about object oriented programming, and mainly focusing on the syntactic issues as well as the different features. But from the designer's perspective, maybe as a designer you may not be bothered about what language you use to implement, and how you actually what syntax actually use. So that is not the issue, but the issue is given a very uh, uh, given a real world problem, what should be the class design that should be suitable for uh, So that is scalable, that is upgradable and all this. So that is one issue, and that's why object oriented design itself, as I mentioned, can be or it is often treated as an individual or a standalone course. And those designs, if you know C++, you can design in C++. If you know Java, you can implement in Java, like that. But there are different design principles people thought of, which one is better. They have analyzed uh, the overhead of maintaining that design, updating that design. There are different software engineering metrics, and in fact, this is also this topic has been discussed extensively in the software engineering course also sometimes. Okay, object oriented design. So one simple principle that we can just mm, get out of the discussion, and there are many such principles based on which the designs are made. One such design is the composition can be preferred rather than inheritance. Whenever it is possible, or wherever you think that it becomes too complicated, you can or you have the choice of both, so you should stick to composition rather than inheritance. Okay, and there is a book by design by Gamma et al. Named as Design Patterns, which is a very popular book, and it was published long back in mid 90s, and still it is popular uh, as a book to understand object oriented design. Okay, so in words we can say that it is more natural to build business domain classes out of various components than trying to uh, find commonality between them and creating a family tree. That means it is hinting towards having a design which more uses or prefers composition. Okay, you see, it is composed of various components, so it prefers composition rather than creating a family tree. That means inheritance. So that is the broad design principle that probably a designer should follow. Any question? Hello? Let me get into the typecasting. Anyway. Okay, so now we'll focus on a specific example of inheritance so that you know how to use all these features, how to use, I mean, what will be the exact syntax of implementing an inheritance based design. Okay, so what I intend to talk is about having a list class. List. So what is a list? So list class means list can be anything. So it's a, you can think of it's a one dimensional uh, arrangement of elements. It's a list. Okay, so 2 3 5 9 1 15, like this. So it's a list. L. So list is one of a very basic data structure. Sometimes it is also I mean, more technically it can be. So in object oriented terminologies, they are implemented as a vector. Okay, so if it is a list, so how it can be implemented internally, what kind of data structure can be used to implement a list of numbers or list of elements, what can be the underlying data structure. Hello?
We can use arrays.
A bit louder, I cannot hear you.
We can use arrays.
So we can use arrays. What are the other options? What are the other options?
Linked list.
Hmm? Hello? Can somebody answer, because I'm not getting the voice. I don't know what's wrong. Can you speak a bit louder? How a list can be implemented? One is using arrays. What is other possibility?
Linked list, sir.
Hello?
Linked list.
Linked list. Okay. So we'll stick to in our particular design, or in our particular in this particular example, we'll stick to the implementation of arrays, right? Now, if you think of a list, so list, what can be the methods that can be included in it? So you can insert in the beginning of the list, you see. You can insert at the end of the list. You can delete from the beginning of the list. You can delete from the end of the list. And let us assume that we are not considering right now insertion deletion that takes place in the middle of in between. Okay, so it will be either from the beginning or the end, or whatever, maybe from both the beginning and the end, like that. So that is our basic say understanding. And we have got some way of displaying the list also. So display list, then begin, insert begin, insert end, delete begin, delete end. Okay, so these are the kind of uh, methods that you can expect. And you have got the data structure as an array. So maybe arr, array is the data structure, and these are the methods. And we can definitely consider a dynamically allocated array for this. Now, if I think of a stack and queue, stack and queue class, so stacks and queues are also lists, right? Can I say that stack is a list and queue is also a list? Can I say that?
Yes,
With some
yes,
special
sir.
properties? Hello?
Yes, sir.
So this is a very obvious design, right? Now, when I think of queue, we can also talk about double-ended queue, right? So double-ended queue is a queue. So this is a queue, but with some special properties. So in a queue, you have got deletion from one end and the insertion from one end. But in the double-ended queue, you can do insertion deletions from both ends. So a DQ is more of a this generic type of list that we talked about. Okay. And sometimes we talk about priority queue, right? So priority queue is also a queue with some special properties. So there is the deletion is based on the priority value, and we have to add corresponding to each element, we have to add the priority information. So this is fine. So now let us see that. So this is a queue is a list, stack is a list, DQ is a list, priority queue is a list, like this. So let us see that how this inheritance design can be implemented. Or in other words, we say that what should be the mode of inheritance that we should follow. So what may the modes of inheritance in each of these cases? What are the possibilities? What way a particular class can be derived from another class? Hello?
Tree-based.
What is the mode? What are the possible modes?
Public, private, and protected.
Yes, so it is private mode, protected mode, and public mode. And in fact, in all the classes that I have taken in the dynamic during that dynamic binding and all, I prefer to stick to public mode of inheritance, because this public mode of inheritance is actually is a relationship. So this is a relationship is basically modeling the public mode of inheritance. Can you tell me what is modeled by private mode of inheritance? What is the semantic of that? What is the meaning? Can you recall from your inheritance class? Anybody who can recall? So Haza is basically composition type. It's not an inheritance, it's composition. But this private mode, it's sometimes better known as Haza. Got it?
Yes, sir.
Hello? Are you getting me?
Yes, sir.
So this private mode of inheritance is often referred as a kind of relationship. So stack is implemented as a list. So as if it is a list, it was that. It's not an inheritance, it's a So this class what we have, just focus on this first. So in the list class, we'll have the data, the array of max size, in front rear size. Okay. So front means the beginning of that list, the rear means the end of the list, and the size is the total number of elements that is there. And the methods are insert begin, insert end, delete begin, delete end, is empty, is full, as well as display. And the point is because it's an array and we will insert from here, here, here like this, and if we delete from this end and if this is full we can store it back. So the thing is we would expect it to be implemented as a circular queue, sorry, a circular list. So this list will be maintained in a circular fashion. Okay, the way the circular queues are maintained. So if you hit this extreme end, you go for modulo operation. So you modulo you. So every time you increment the index where you store the element, it will be modulo incrementation. Okay, and because of that, and still if there is no space or not, you check it using is empty and is full. So no matter what the list should be used, the basic list definition, but these are the basic methods that we can assume that any list class should be having. Okay, now this display, we may decide to have this as what kind of function it is. I wrote display equals to 0. That means I would like to have it implemented as hello,
Abstract, virtual, sir.
virtual.
Abstract. The list class will be abstract, sir.
So this will be display equals to 0 means it will be a virtual function, but it will be this list should be a
Abstract class.
what type of class it will be?
Abstract.
Abstract based class, because it is not defined completely, right? So we can do that because in the rest of the hierarchy, as you can see, the stack and the queue, maybe the stack we would like to display it like this. When you draw the queue, we probably would like to have it implemented like this. This is rear, this is front. So it has got a different way of visualizing. So that's why I say that, okay, we don't know how you are going to use it. So let us have it to be pure virtual. So we say that It's a pure virtual function, and which makes this list as a abstract base class, right? So you cannot, so in other words, we can say that the list, we say that there is no list as such, a list object that will be created, because list is just a very generic base class from which the stack, the queue, the dq, all these are inherited, and these are concrete classes for which you can create an instance. Okay, up to this, is it clear? Hello, hello, a bit louder.
Can you repeat why you wrote display equal to 0?
Please speak a bit louder. I don't know what's wrong in it. I cannot hear you clearly because of the speaker. I think.
Sir, can you please repeat why you wrote display equal to 0?
Okay, no, this is you might say that this is just an maybe an option just to show that, okay, how that feature can be implemented here. We may not include it as a pure virtual function here. We may not, because after all it's a linear list, so you have to just display the elements maybe separated by comma. That I understand, but I have just intentionally have done that to show the syntax of having a virtual base class and I mean, sorry, the abstract base class as well as the pure virtual function. But one probable logic can be that this list, we don't have a list which is neither a stack nor a queue nor a dq, like that, as one dimensional list. Whenever we deal with one dimensional list, probably we deal with lists which are of these three types. I mean, let us assume like that. So that's why I don't want a concrete instance of this list class to be created. So that is also one reason I make it virtual. So if I make one of the function virtual, the whole class becomes abstract, and once I have the concrete derivations from that base class, now the display for the stack I can have this kind of display, for the queue I can have this kind of display, and that way it goes on. But again, there's probably not very strong logic of why I prefer to make it pure virtual function. Is that okay?
Yes.
Hello? May I proceed?
Yes, sir.
Okay. So now, so let's so first of all, I would like to focus on this portion, and here is the code. So let us quickly go through the code. I think the rest of the code is trivial. Everybody can get it, and I'll share the slides also and the actual code also. So you see, class list is written, and this is the end of the entire interface. This is the array, and I have decided to make it static for simplicity. I could have made it dynamic also. Now we got the constructor with default argument. We have got the destructor with proper prompts and all. We have got insert begin, is full, is empty, and all this. And here I am defining the, and here is there is bool. So bool is implemented using enum. So using the enumerated data type, the bool is defined. Let us assume that it is defined somewhere. So is full, is empty. These are all trivial. I am not going to the details of it. And this is list display. Okay. And this I have not mentioned it as to be uh, a pure virtual function, or maybe it is like this, and I have defined it also. So that means it you have defined something, but you still want it to be abstract class. Okay. So let's not bother about whether we make it display as pure virtual or simple virtual, whatever. So that is not the major issue. I would like to focus on the inheritance mode and all this in this particular example. But if you want, you can make it okay. Let it be concrete and all this. If you want, that's not the major uh, problem here. You have both the options. Now this insert begin, you see, and we are checking this, and this is how it is done. Okay, we are checking is full and all this, and insert at the end. It is also like this, and this is delete begin, delete end, and then we have created an instance of a list, and these we are calling, and it works fine. Okay, so can I skip this slide? So this is very trivial. Is this okay?
Yes, sir.
Yes, sir.
Now let us see. We are trying to first derive the inherited class stack from the list. Now you see in the stack what happens. In the stack, so this part is fine. So this part as it is you get inherited. So data part, you need an array, you need front, rear and size, that's fine. But in addition to that, probably we basically use the index as top. So top is the more well-known term when we define a stack, right? So I would like to define that in addition to whatever is there. And I would like to see in the constructor of this stack what top should be set to. So apart from this, I would like to have this top. And apart from these interface, so in the stack, do you ever use this delete from the insert at the beginning or insert at the end? In the stack, the insert in the open end. Now, whether you call it in the beginning or the end, it's up to you. But the thing is, uh, if this is the list, and if I say this is the beginning and this is the end, so the first element, second element, third element, fourth element. So basically, you can say in terms of the stack, so which end you should perform. So which of these four functions, out of these four functions, you are basically you will be using in the stack. Say the push and pop stack, the operations are better known as push and pop, right? So what pushing means? Push means whether it is inserting in the beginning or the end. So if I try to write push in terms of these four basic functions defined in the list, so how push should be implemented as, or which method of list push should call? Got my question? Hello?
Yes, sir.
Hello?
Yes, sir.
So can you tell me the answer? I mean, it's already written, but can you see the answer? I mean, what push should call? So I say that this is a list, this is the beginning, and this is the end. So I say that in the list is the beginning. So the first element is here, so it is beginning, and then once the second element to be inserted, so this becomes the end. So here it is inserted, here it is inserted here, and when you delete also, we delete from this and this and this and that. So if we have got begin, insert end, delete begin, delete end. So when we talk in terms of a stack, so which of these four functions or four methods it should be using in its push and pop operations?
Insert and in push and delete and in pop.
So push should be insert end, right? Because pushing means you are inserting at the end, and pop also it should be deleting from the end. And the display means if you have got a display something that I displayed here, you can display, and then you can, in addition to that, you can put a tag of the top and all this. You can nicely have the annotation of that list instead of just displaying the number. So that you can do. Okay. So the question is, apart from this inserted and deleted, do you want to release? Do you want to provide the user access to the insert begin and delete begin also, these two methods? Because see, stack is inherited from the list, so everything that has been defined here will be passed on here. I mean, trivially, if you make it public, see, if you make the inheritance public mode of inheritance, so everything that was here would have been translated here. I mean transferred here. So in the stack, if you are using a stack object and if you are called insert begin, it will work. If you call delete begin, then also it will work. But I do not want it to work. So how to make it happen? So stack is a list, but it is a special type of list where I would like to use two of these methods, but I do not want to use the rest of the methods. So what can be the mode of, if I make it public, so everything will be available.
So we can make it private, sir.
A bit louder.
The private, we can private.
Hello?
Sir,
Private,
our
sir.
open up elective class has started.
I'm not getting, there are multiple voices. Hello?
Inherited in private mode.
If I go for private, then what happens? If I inherit it privately, then what happens? So everything that you have got here, they will be inherited, right? But they will be treated as private. So you can see this from this class definition, but from outside, anybody who is trying to trigger the methods using some object, can they trigger these private methods?
No, sir.
If you have stack, say S1, so can this S1 invoke, say I would like to invoke what is this insert end. Can I do this? If I inherit privately, it is not possible, right? If I make it public, then what happens? I can do this, but I can do this also. S1 dot insert beginning also can work, but this I don't want. So got the problem?
Sir, we can use protected mode, public in the class and elsewhere it will be private.
If I make it protected, then what happens? So protected means everything is visible here, but it will be treated as private, right? But you can pass it on, so you cannot access them from, so this is not possible, but you can pass it on to the next level. So protected also will probably would not have helped us, right? First of all, are you getting the problem, what I mean to say? I would like to inherit, but after I inherit, I would like to shield, I would like to mask some of the methods. I would not like to reveal some of the methods I inherit, but I would like to reveal some of the rest of the methods that I have inherited. And that too, I don't want the user to say that s1 dot insert end, because insert end in stack there is no insert end. Stack says that I can push and pop, the operations are this. So I would like to give a new name to that operation. Might be I am doing the same. So are you getting the basic problem here, the basic design problem? So what should be the mode of inheritance, and how should you define the push and pop so that it is reusing the most of the inherited part and not also revealing the unwanted part of it, and also trying to retain the kind of operations, the names that you'd like to prefer, like the push and pop and all this. Are you getting my point? So the rest of the story is very simple, but are you getting this problem? I mean, how to design? or how to design a inherited class from some existing class. Is that fine?
Yes, sir.
See, so if I, so this solid dot, I mean dashed, sorry. So if I if I make it private, so if I make it private, then what happens? So these becomes inherited, but they are not visible. Now if I write a push and a pop separately as new interfaces for this tag, and then I can write push, but I can, instead of writing the entire logic, I can simply make a call to lists, because it is so list this scope resolution insert end. So I
Hello,
reuse
sir.
this. Yes.
Excuse me, sir. Sir,
Yes.
our open elective class has started.
Okay. See, I think we have very little options. So those who are having open electives, they can leave. I will take another 10 minutes of class, and those who are
Say
leaving, they
everyone
can
have
listen to
open
the
elective.
video. That is possible. Because I am also not feeling well. I have undergone a test. Might be that tomorrow or day after tomorrow, the reports will be positive, and I don't know what is going to happen. Okay. So those who are willing to leave, I mean, they have other classes, you may leave. The rest, if somebody is there, I can continue the class, and the recordings you can listen. Will that be fine?
Okay, sir.
Say everyone have open elective actually.
Hello.
Say everyone have their open elective classes right now.
All of the students are having.
Yes, but I
Yes.
mean those classes are different, but everyone have their
Okay.
classes.
Okay.
It's a
Okay.
scheduled
Then
time,
there
sir.
is. Okay. Fine. Then I have to then stop the class. Okay. What I can try is having some offline recordings, and I can pass it on to you. Okay. Let me stop the class. Then I'll decide. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Any questions? Anything else?
No, sir.
Do you have any questions? Okay. Then I'm leaving.
Thank you, sir.
Thank you, sir.
Thank you.